Hi guys, in this video we're going to be learning about changing states. We'll look at specific latent heat. We'll be classifying specific latent heat. We're looking at energy calculations, latent heat and heat capacity, and finally a summary.
Let's start by talking a bit more about changing states. Well, when a substance changes state, the energy and arrangement of its particles changes. For example, when a solid changes to a liquid, we find that the particles become more energetic and they're less strongly bonded to each other and less ordered. So how does this change in arrangement actually happen? Well, particles are held together with things called intermolecular bonds. And when we change the arrangement, intermolecular bonds must be broken or formed. So for example, if all of the particles in a material have intermolecular bonds like this, then this tells them where they all kind of need to sit relative to each other. On the other hand, if we break these intermolecular bonds, then the particles are going to have more choices about how they can arrange themselves. So changing state is all about making and breaking these intermolecular bonds. And the energy needed to make or break the bonds is related to something we call the specific latent heat. And because this is about the energy for breaking and making bonds, it's also about the energy for changing state. So what is the specific latent heat? Well, we call the energy required to change the state of a substance the latent heat. And then we define the specific latent heat in the following way. The specific latent heat is the energy required to change the state of 1 kilogram of a substance without changing its temperature. One interesting thing is that we have this energy change, but we know that we can change between states in both directions. And in one of the directions, energy is going to be released, and in the other direction, energy is going to be taken in. Let's see how this works. Well, when we heat something, it's taking in energy to break the bonds. Well, when we leave ice out in the warm, then it takes in thermal energy from the surroundings, and this thermal energy goes into breaking the intermolecular bonds it has that keep it so rigid.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific GCSE physics and combined science videos, just click on the SnapRevise smiley face. Join me today and let's make physics at GCSE a walk in the park.